Irodov problem number 1.242. Using the formula for the moment of inertia of a uniform sphere, find the moment of inertia of a thin spherical layer of mass m and radius r relative to the axis passing through its center. Okay. So, for a sphere, if we calculate the moment of inertia about an axis that is passing through its center, okay, we know I is 2 by 5 m r square, where m is the mass and r is the radius of the sphere. Okay. Now, we have to find the moment of inertia. This will become a little bigger. We have to find the moment of inertia of a shell about an axis that's again passing through the center. Shell, this is what is thin spherical layer of mass. Okay. It only has a thin thickness, inside it is hollow. Okay. So, how can we find this out? Let's start with this. So, I of a solid sphere is 2 by 5 m r square. Now, I do not want to deal in m, I want to deal in density. That is the property of the material, because mass will change. For a shell, mass will be different. In fact, we have to find the I for this, where its mass is given as small m and radius is capital R. Okay. So, now we know density is mass by volume. So, m is the mass of the solid sphere. What is the volume of a sphere? It is 4/3 pi r cube. So, mass we can write as rho times 4/3 pi r cube. So, let us do that. So, this becomes 8 by 15 rho pi r to the power 5. Now, let us say this is I. If I differentiate I with respect to r, di dr, okay, then what will happen? Everything else is a constant. 8 by 15 rho pi, this will be 5 r to the power 4, or this will be 8 by 3 rho pi r to the power 4 di dr. Okay. Or we can further write this as a small moment of inertia is 8 by 3 rho pi r to the power 4 dr. Okay. Now, a small change in radius will result in a small change in moment of inertia. That is how I read this. So, now let us come to the shell. Okay. For the shell, can I write the mass of the shell, let us say it is dm, is the surface area of the shell times the thickness dr. If this is thickness is dr, the small mass dm of the shell is rho times surface area of the sphere is 4 pi r square, 4 pi r square, and then this thickness dr gives me the volume. So, volume times density is the mass of the shell. Now let's look at here. Di, we said, is 8 by 3 rho pi r to the power 4 dr. If I can separate out, so let's say 2/3 4 rho pi r square dr times r square. Okay, r to the power 4. Okay, so this becomes 2/3. Now what is this? This is the mass of the shell, dm r square. Okay, now we got this expression in terms of a small mass and small moment of inertia because of that small mass. But if we integrate, and we can write this expression as I equals 2/3 mr square. That is the moment of inertia of a shell of mass m and radius r. Okay, so that's my solution.